doing something fun and fancy free. So filling in some missing stuff from Unit 3. Other questions? So that was number 7. So the next part is find the equation of a tangent line with a graph of when x equals 3. We've got the derivative already. You have the point already. So just plug both those in. Okay, number 9. Equation of a normal line with a graph when x equals 3. Correct. So instead of negative 3 over 4, it becomes positive 4 over 3. Okay, and then 10 is separate. It's not a part of these 3. At what values of x does the graph of h of x is equal to 1/2 x squared square root of 2x plus 1 have a horizontal tangent? Show your work and give your reasoning. For this kind of problem, it's important to remember what this phrase means. Horizontal tangent, this means your slope is 0. And if your slope equals 0, that implies that f prime equals 0. So this is asking for where your critical values are.
So you do n equal to 0?
Yep. And this would be a product rule with a quotient inside of it. For ones like this one, I'll use this shortcut on this problem because one of the 2 pieces is that square root. So that'll help shortcut a lot of the work if I do it correctly. Or I can just, go through it normally and do a chain rule. I don't want to go too fast. So you set the pace. You tell me to move on or not move on.
That one I got.
Okay. 11?
That one was just 7.
12? This thing? 13. Graphically, identify a value of x at which the function is continuous but not differentiable. So continuous, remember, means that there is a value and it is the same value as approached from the left and right hand side. Differentiable means the slope has the same properties. So the slope matches from the left and right hand side. In other words, there's no sharp points, there's no jumps or asymptotes. It has to match from both sides. In this case, because my function has from the left hand side a negative slope, but from the right hand side a clearly positive slope, it's not a 0 in between them that makes this not differentiable. Because it's clearly not a place where it's going to level off. But at the same time, it's definitely a place where something weird is happening. This is a common issue with differentiability, or having a derivative. From the left of this point, there is a clearly defined derivative. To the right of this point, there is a clearly defined derivative. At that spot, there is not a clearly defined derivative because it's doing different things from both sides. 14? Write an equation of h of x and show analytically that h of x is in fact continuous at x values that you identified in exercise 13. Show and explain. So this is a piecewise function. And so I would just do it as 2 pieces. The left-hand piece is a linear equation. I'd use a couple points by the linear equation for it. The right hand looks like a quadratic, which it is. And so I use that to find the other one. Let's see. Out of all the problems on here, 14 was surprisingly a lot of work, just because you have to find 2 equations. But otherwise, it's pretty straightforward. You gotta see it as both pieces.
I think 15 was the one using this one.
Show analytically that h of x is in fact not differentiable at the x value that you identified in exercise 13. Show and explain your work. So once you have the equation, what you can do is, the way differentiability works is the derivatives have to match. So you can take the derivative of a piecewise function, which would be just take the derivative of the left piece, derivative of the right piece, and do they match? So let's go ahead and do 14 real quick. So 14, I need to find my function first. So it's going to be piecewise. So this is h of x. Alright, here's my pieces. Alright, the first piece starts at -6 and it goes until 2. The second piece starts at 2 and it goes until 6. I'm not sure which of these is included, so I can just put one of them for now. So I might put that one, for example. When it comes to the actual derivative, it doesn't matter which one it is, because the point is they should match. And so as long as they're both there, it's fine. Alright, left-hand one. So for a linear equation, I'm going to use the standard y equals mx plus b. I think that's the easiest one here, because I have a y-intercept for that equation, and I can find the slope very easily by just using a counting technique from algebra 1. So no y equals mx plus b, so x plus b. Intercept is at positive 2. My slope, I'm going down, so that would make it negative. And I'm going right to down 1, so I do rise over run, so it'd be -1/2. You can see that clearly. Down 1/2, down 1/2, down 1/2. And the other one, I'm going to use from algebra 2 vertex form, which is the ax minus h squared plus k. That's vertex form from algebra 2, where h and k are the vertex, and a is the amplitude. Which for this one, it turns out the amplitude is -1. I'll show that in a second. But let's start with h and k. So I can see here, the vertex is very clearly at 4, 5. So I'm going to plug those two things in. This would be x minus 4 squared plus 5. Now I just need to have this number be correct to do that. I can do it one of two ways. I could pick a different value, like say 5, 4, and I can plug that in and verify what the number should be. That's one of the main ways you can do it. Alternatively, I can see this opening downwards. That makes sure it has to be negative. And remember, for parabolas, there is a basic form for every parabola. If a is 1 or -1, it will always follow the first step is 1, 1. The second step is 1, 2. That's how it always works. For a standard parabola, you can check that by one of the properties. And I see that is the case here, so that must be the amplitude. Now that I have these two, so I've answered question 14. Answering question 15 is a matter of taking the derivative of h prime. That's what I'm going to do next. H prime of x. So the derivative of the top one is relatively easy. The derivative of this one would be -1/2. That's not too bad. But it'd be -1/2 from -6, let's make it equal to x, let's make it equal to 2. For the other one, it's not going to be as nice, but it's going to be an equation. And you might want to actually follow this thing out to make it a little simpler. It's kind of up to you what you're into. I think in this case it might be a little difficult to pull it out, so I'm just going to take a chain rule. So according to the chain rule, I would multiply by the power, so this becomes -2, x minus 4. Drop 1 from the power, so it's going to be 2, you have a power of 1, which would just make it nothing. And then multiply by the derivative of the inner component. Derivative of x minus 4 is, of course, 1. So it doesn't do anything. Plus 5, derivative of 5 is 0. So that's our derivative. Now the question is, what's happening here at 2? So this is h prime, but I want to know what's happening specifically at 2. Well, on the left-hand piece, which for my list is the top one, well, from the left, h prime of x, or h prime of 2 in this case, is equal to -1/2. So we could say something like, the limit as x approaches 2 from the left of h prime of x. If we want to use terminology from our first chapter, but it's all the same. From the right-hand side, So our limit as x approaches 2 from the right of h prime of x. So I plug 2 into this equation. When I plug 2 into this equation, I have 2 minus 4, which would be negative 2, times negative 2, so it would be positive 4, times 1 would be 4. I can clearly see that these two do not match. And thus this is not differentiable. To be differentiable, the two must match. It's also why if you look at this picture, like it's clear this place looks different from everything else. It's continuous, so it has a dot everywhere. And the dots don't, have breaks or asymptotes in them. But still, it's doing something wonky. It's out of order, out of place. What else?
I think I made 116.
Okay. Given the graph of h of x pictured above, find the equation of the tangent line of the graph of p of x equals the square root of h of x when x equals 3. Okay?
Don't you just take like what h of x is and put it underneath the square root?
Yes, but specifically when x equals 3. That's the key component there. Because there's two equations, right? But only one of these is being applied at 3. So I'm going to use this specific equation and plug it in and see what happens. So if this p of x would be equal to the square root of negative x minus 4 squared plus 5, because we're specifically at 3. If it had said at 1, I'd have to use the other equation. So change it up.
So they use 5.
So, yep, p prime of x. And again, I'm going to use that shortcut we had before using the u's. So this would become, okay, on top would be u prime. The derivative of the inside would have a chain inside of it, but that's okay. I've already done that problem actually once. The derivative of the inside should be this. Notice how I reuse my work. I don't do it again. Reuse work. So the top should be negative 2 x minus 4. So the first power times 1. I'm just going to leave it like that. And then on bottom, we end up with the square root, 2 times the square root of negative x minus 4 squared plus 5. Now I could choose to simplify some, like I could get rid of the 2's, right? But really I just want to find out what happens at 3. So I'm going to do p prime of 3. So I plug in 3, so I have negative 3 minus 4 over the square root of negative 3 minus 4 squared plus 5. So on top, I end up with a positive 1. 3 minus 4 is negative 1. Negative of that will be 1. On bottom, I end up with 3 minus 4 would be negative 1. Square that positive 1. Negate that negative 1. Plus 5 would be positive 4. Square root of positive 4 is 2. Their value of 1/2 when I plug everything in. And again, I use my shortcuts there to make that process a little simpler. I don't have to use shortcuts, of course. This makes it a little faster. Otherwise, I have to do a power rule with 2 chains inside of it, and that's annoying. Too far? Okay, 17 to 20.
Just like plug all those in
Yeah.
on like a graph.
You just gotta make sure it matches everything it says. And that's, for some, like these are clearly points. You just gotta draw those points. But then you have to make sure it's in that picture. Is it increasing? Is it concave up when you connect dots? And keep in mind, when it says increasing, that means it cannot level off. Because if it levels off, that means it's not increasing anymore. So it has to make sure to still always be a positive slope versus increasing. Always be a negative slope versus decreasing. Never leveling off. Otherwise, there's a big difference. Okay. 18. Good. Let's start by graphing this. Because if we graph it correctly, then these two become easier to estimate. All right, do it. All right. Okay, I'm going to do all the points first because that's the easiest thing to do. -4, -5, -4, -5, -2, -4, 2, -4, -1, -2, -2, 0, 1, 1, -1, 3, -2, and 5, 0. Okay, I want to connect these dots, but in a way that keeps it from -4 to 0, increasing and concave up. Remember, concave up is the U shape, concave down is the N shape. So I want to concave up. That looks pretty easy, like so. So I verified, is this increasing? Yes, the slope is always positive. Is it concave up? Yes, it is opening upwards. Perfect so far. Over here, I want it from 0 to 3 to be decreasing and concave up. From 3 to 5, increasing and concave up. Okay, let's look at our picture. It's asking us to estimate the value of h prime of -2, so that means the slope at -2. So right here is the slope. And h prime of 1. So that's right there. So take a look at the picture. Estimate. What is the slope at -2? What now? A trick you can use for this stuff? Draw a rough tangent line. The tangent line should have the same slope, right? So, come on. Okay. Draw a line that you think is tangent to that one.
To this one?
This time, yep. Beautiful. I'm going to now use rise or run to determine the slope. Rises 2, runs 2. What's the slope?
1.
There you go. So yeah, just make a tangent line and then use rise or run. Keep it simple. Don't overcomplicate it, right? In fact, like on the next one, like I'll draw my tangent line, and if I don't have nice values, I'll keep extending it out as straight as I can until I have two numbers that I can easily do rise or run with. But this one, actually, I think this one's not too bad. I could probably get real close right there. So again, you rise or run. This goes down 2, over 2, not 1. Do these values support the claim that h of x is increasing on the interval -4 to 0? Well, what's it mean to be increasing? Going up. In calculus, what's it mean to be increasing? Positive slope. Or the derivative is bigger than 0. Does that support the claim?
Mm-hmm.
Yes. Give a reason. Slope's bigger than 0. The derivative is bigger than 0. Any of those would be good. I believe 19 asks about, does it support the claim that it's decreasing? Is that correct?
I think so.
In that case, well, I think so. This is a nice, nasty, dirty little trick you can use if it asks you to estimate. just draw the tangent line, because tangent line is an estimation of the slopes. It's raining. Alright. 19. Determine the values at which h of x is not differentiable. Give a reason why h of x is not differentiable. What a picture looked like? It was something like that, I think. And then like that.
Yeah.
So would it not be differentiable? Yep, I need it. Give a reason? Well, you could say the slope from the left does not match the slope from the right. That'd be a good definition. Remember, we talked at the beginning of derivatives that a derivative can always be written as a limit, right? We use this old definition, limit as delta x approaches 0 of f of x equals delta x minus f of x over delta x, right? We use that old one. That's the limit. Remember, limits have to agree on both sides. So if they don't agree on both sides, the limit must not work. And if this is supposed to be our derivative, if they don't agree on both sides, then the derivative can't. Okay. On what intervals of x is h prime of x bigger than 0? Give a reason for your answer.
It's like taking a graph and turning it into a derivative. That's what I get stuck on.
Okay. So ask the question a different way. What does this statement mean? H prime of x is bigger than 0.
Wait, the slope bigger than 0?
The slope is bigger than 0, so it's another way we've said that in this class. The slope is bigger than 0. You are like actually going far deeper than I wanted. You have all the right ideas. Think simpler. H prime of x is bigger than 0. So yes, the slope is bigger than 0. The derivative is bigger than 0. All those are true. How would you explain it to an algebra 1 student? Not using calc terms. It's what?
The slope is positive.
The slope is positive. Or?
It's increasing.
Decreasing. Anybody could understand those terminologies as long as they had algebra 1.
So then when she's here, the -4.
This would be one place where it's increasing?
And then leave it.
Yep. So this statement right here, like you just mentioned, 4 ways we could write this. Right? We could say the derivative is bigger than 0. We could say the slope is bigger than 0. We could say the slope is positive. We could say the slope is increasing. They all mean the same thing. They're interchangeable words. They're all the same. And so at any point in time, if you see that statement, you can switch in for any one of those terms. If I have to do calculus, I want this, because that tells me what to do. Take the derivative and make it bigger than 0. If I want a graph, well, I'm probably looking at one of these two, because these two are easier to understand conceptually what it looks like. Whereas if I want to like explain this like in terms of a function, slope bigger than 0, that's one I can use. So each one has its own separate uses, but they all mean the same thing. Think of them as synonyms. English? I can English. Alright, that was fun. Where are we going next? Okay. The graph of x minus 2y is equal to 9 is parallel to the normal line to the graph of f of x when x equals 5. What is the value of f prime of 5? Okay, there's a lot of terminologies here. Let's talk about this one piece at a time. The graph of x minus 2y is equal to 9 is parallel to the normal line, the graph of f of x when x equals 5. I'm going to ignore the last part for a second. Let's discuss what this means. It is parallel to the normal line. What does the word parallel mean? Very visual, yes, love it. In calculus, what does that mean? There's a couple ways we can talk about it. So that's the visual form. That'd be like a geometry style answer. How do we talk about parallel in algebra 1? Same slope. So what's it say? The graph of x minus 2y has the same slope as the normal line. The graph of f of x when x equals 5. Okay. So this has the same slope as the normal line. Now, what do we know about the normal line compared to f prime? So we know this is, so it's has the same slope as something perpendicular. And what are we asked to find? So this is the actual slope. This is the slope of f. What we have is something that has the same value as something that's perpendicular to this slope. There's a lot of pieces here. But what we have to do is actually pretty straightforward. Ready? Step 1. It has the same slope. I'm going to find that slope. Step 1. X minus 2y equals 9. Let's find the slope. How do I find the slope of a linear equation that's written this way? Y by itself. Do it for me.
2, you have to subtract x to the other side.
Okay.
Use negative 2y equals 9 minus x. Then
Perfect.
by negative 2.
Okay. You probably don't want it in that form. So what form would you want it in?
Which one put it up there? X over 2 and then by negative 2.
So this would be okay. Even so, that's not great, because if I ask you what the slope is, I have to think. How else could I write that?
Can you pull the x out of it?
Uh-huh. Okay. So, my original equation is this equation. What is the slope of that equation? Okay. What is this asking? It says this graph has the same slope as, this 1/2 is the same as the normal line. So the 1/2 is perpendicular to this value. How do I find the value I actually want? That's right. So this is currently 1/2. I times it by the negative reciprocal. So this would be negative 2.
Good thing I shut up.
Yep. We're just going over some questions from the Unit 3 homework that she was not here for. So. And the videos were awful. So. So take a look at the beginning of this problem, and I want you to focus on how we get from what they talked about to the steps to our solution. So what did they give us from the very beginning? This graph is parallel to the normal line of the graph of f of x when x equals 5. What is the value of f prime? I can do it two ways. I can start with the equation and work to f prime, or I can start with f prime and work backwards. Here I will do the other way this time to showcase how it works. F prime of 5. What does this mean? I want the slope at 5. What do I have? Well, I know something that matches to the normal line when x equals 5. So how do I find that? Well, I use a negative reciprocal. If I have the slope, I use the negative reciprocal to get the normal line. Well, what do they tell me now? Well, it's parallel, so something has the same slope as this equation. X minus 2y equals 9. So what I can do then is go, okay, well, I can find the slope from this one. It's going to match slopes to that one. And then I use a negative reciprocal to find that one. But it doesn't tell us that in the problem. It gives us a bunch of terminology that we have to recognize. It's all about slopes, just different kinds of slopes. Parallel slopes, perpendicular slopes, slopes found by a derivative. They haven't given me the equation. You have to understand the terminology very, very clearly. And that's tough. Because it's easier if I just gave you an equation and said, hey, find f prime of 5. When I have to understand the concept, it's a lot harder. I smile over here. I don't know if you can tell.
No, I couldn't.
All right. What else, Casey? Oh, wait, Casey's not here. Michael? Clever comment? Abby, sitting quietly in the corner. Alexis? Equally quiet but in the front. JJ? I miss you. I miss you, JJ. I hope you're back soon and healthy and well. They probably won't watch the video, so I can say whatever I want. Ah! Alright. What else?
How would you find
Set it equal to 4.
Set the derivative equal to 4. Well, what does it say? All the points of the graph, the slope of the tangent line is 4. Well, that tells me the slope of the tangent line is 4. It tells me the derivative is 4. So what do? I take the derivative, it equals 4, and then I solve. It's probably going to end up being a quadratic equation problem or a factoring problem of some kind. One or two. Answer should be 1/3 and
Just the one where you have like 5 answers.
1. No. We only have 2 answers. I'll do it real quick. Step 1, find the derivative, 3x squared minus 4x plus 5. I want it when it is 4, so when the slope is 4, so when f prime of x equals 4. Subtract 4 from both sides, 3x squared minus 4x plus 1. And then factor 3x minus 1 times x minus 1. 1/3 and 1. So I said it right. Boom! Still got some skills. Don't rewind the video. So I guess this one is, they've told us the slope of the tangent line is 4. What does that mean? This means f prime of x equals 4. And it's in that list of synonyms we talked about. If it's the slope of the normal line is 4, then I want to do an inverse or negative reciprocal and then do the exact same process where f prime equals that number. And I can always go back and test this. At 1, keep in mind, this is the original function. This is f prime. At 1, this will give you an answer that is 4. 1 squared is 1 times 3 is 3, minus 4 times 1 would be negative 1, plus 5 would be 4. So the slope is 4. At 1/3, same thing will happen. A little more complicated, but it does work. And so this is the places where we would have a tangent line, is 4.
I think she's gonna throw all the terminology in there for the last.
It's a lot of terminology. If you get the chance to actually open the book, like 90% of every section is words. There's very little actual math in them. It talks about the definitions, it talks about how they fit together, because that's the part that's trickier. You know, the math itself isn't really hard. It's being able to take a problem like this, convert it into the math steps. Because once you get to here, you're like, oh, that's algebra 2. The calculus part is, can you interpret what this says to get to an equation? And that stuff. That's why you get paid the big bucks.
Variables of increase and decrease.
Yep.
And maximums.
Yep. So 5 critical values. We did that already in this section. Then give it back to you, believe. How do you feel about these?
I haven't started them yet, but I feel like once I get like on and actually figure out what I have to do.
Okay. Just testing your rules and stuff, you know. Product rule, quotient rule, multiple products. Do always note in the problem whether you're given f or f prime. F prime changes your steps because you don't have to do one of the steps. Second derivative test final Sherman, so same concept. In the second derivative. Remember, if it's concave up, you're going to have a minimum. It's going to be that U shape as a bottom. Concave down is going to have a maximum, and it's the N shape as top. Integrals of concave up and concave down. This one was easy. If you remember, e squared is just a number. 31. That's when we had a bunch of solutions. It was easier if we rewrote it at the beginning. Otherwise, this became rather nasty rather quickly. The way we rewrote it in class was we took this x that's on the outside, changed it to the square root of x squared, and distributed it through, giving us 9x squared minus x to the fourth. And as weird as it sounds, this is much easier to do the derivative of. It just is. That's a valid step. It's just weird. Good deal. Again, make sure to double check whether you're given h or h prime. Since I'm given h prime, I want to find the concave up and concave down. I need a second derivative. I already have one. I just have to take another. You're given a picture. Making sure to use the correct sign. So people in class would admit it's a little tougher than it's supposed to be. Like, it's just a sign. You're not trying to estimate. Like, is it positive 3? No, it's positive. Just positive. Okay. Question. If for all the numbers x f of x, sorry, f prime of x is less than 0 and f double prime of x is greater than 0, which of the following curves could be part of f of x? Explain the reason for each graph, whether it is or isn't. So keep in mind, f prime is less than 0. Interpret that information. What does f prime being less than 0 mean? Decreasing. Look at these graphs. Are any of them decreasing?
Question.
What's wrong with graph A?
It's going.
So what would you put for your reasoning? We want it to be that prime is less than 0. What's actually happening? That prime is greater than 0. What about B? What's f double prime of x mean? F double prime of x is greater than 0. So double prime is concavity. If it's bigger than 0, what's that mean? Positive means it opens upwards.
Aiden Ball and
So it
Catherine
has to be
Savale to the office.
decreasing and concave up. That's how we interpret that information. And you can look at pictures and ask, do both those things happen? Well, this one, half's concave up, half concave down, and it's always increasing, so it fails on 2 fronts. This one is concave up, but increasing. This one is concave up, but decreasing. C is a carcination.
So 3, 1, 1.
Mm-hmm.